There is a river under the sea, and it has its own waves. This isn't a metaphor, it's a real place where water flows through water, carving canyons into the seafloor. It looks impossible, like a glitch in the laws of physics. But deep beneath the surface, a separate world exists, with its own currents and even its own shorelines. Divers who have seen it say it's like discovering a secret dimension. How can a river have banks when it's already at the bottom of the ocean? These aren't gentle streams. They are powerful forces of nature, hidden in plain sight. This one, in Mexico's Yucatan Peninsula, is called Cenote Angelita. From the surface, it's just a deep, dark sinkhole. But as you descend, something strange happens. At about 100 feet down, you pass through a ghostly, shimmering layer. Below this layer, the water is different. It's salt water, and it's so dense it acts like a liquid floor. A river of fresh water flows right over it, complete with fallen trees and leaves resting on its banks, as if on dry land. But how did trees get to the bottom of an underwater river? The layer separating these two worlds is made of hydrogen sulfide, a toxic cloud that looks like a misty fog. It hangs suspended between the fresh and salt water, an alien boundary. Divers can swim right through it, but nothing can live inside it. It's a no-man's land. Yet, life thrives both above and below this chemical barrier. So this isn't just one body of water. It's two distinct ecosystems stacked on top of each other, separated by a poison cloud. What force keeps them from mixing? This isn't just happening in caves. The largest underwater rivers are found in the open ocean. Off the coast of Turkey, scientists discovered a massive channel running along the floor of the Black Sea. It's over half a mile wide, and in some places, 115 feet deep. It carries enough water to be the sixth largest river on Earth, if it were on land. It even has rapids and waterfalls, all happening silently, thousands of feet below the waves. What could possibly create a waterfall underwater? The secret lies in density. The water in this underwater river is far saltier, and therefore heavier, than the surrounding seawater. It's a flow of brine, pouring from the nearby Mediterranean Sea through the Bosphorus Strait and sinking straight to the bottom of the less salty Black Sea. Gravity pulls this heavy, salty water downhill along the seafloor, just like a river on land. It's a river made of ocean water, flowing through the ocean itself. But that raises an even bigger question. If these rivers are so common, what else is happening down there that we can't see? The currents of these brine rivers are so powerful, they carve canyons into solid rock on the seabed. For millions of years, they've been sculpting the ocean floor, creating vast, hidden landscapes that rival the Grand Canyon. These are not passive streams, they are active geological forces. They move sediment, transport nutrients, and create unique habitats in the total darkness of the abyss. If they can move rock, what else are they carrying into the deep? Scientists believe these underwater rivers, also known as turbidity currents, are responsible for some of the deepest canyons on the planet. When underwater landslides occur on the continental shelf, they mix huge amounts of sand and mud with water, creating a dense, heavy slurry. This slurry avalanches down the continental slope at speeds of up to 60 miles per hour, scouring the ocean floor as it goes. It's a liquid bulldozer. So it's not just salt making these rivers, it's the land itself, falling into the sea and continuing to move. These events are almost impossible to witness directly. They happen in crushing darkness, miles deep. We only see the aftermath, the massive winding channels they leave behind. One of the largest is the Monterey Canyon, off the coast of California. It's as deep as the Grand Canyon, but it was carved entirely by these underwater avalanches over millions of years. It's a scar on the planet, hidden from all human eyes, until we developed sonar. How many other colossal features are we blind to? These currents don't just carve, they build. When they finally slow down, they deposit the sediment they carry in vast, fan-shaped formations called submarine fans. These are some of the largest structures on Earth. The Bengal fan in the Indian Ocean is larger than the entire country of India. Built entirely from sediment, carried down from the Himalayas by the Ganges and Brahmaputra rivers, then transported into the deep ocean by these turbidity currents. The mountains are literally being moved to the bottom of the sea, one grain of sand at a time. These rivers connect the land to the deepest parts of the ocean. They are conveyor belts for life, death, and geology. They carry organic material from the surface down to the abyssal plains, feeding ecosystems that never see sunlight. But they also carry pollutants. Anything we dump into our rivers on land can potentially be transported into the deepest, most remote corners of the planet. So our footprint extends far beyond the coastline, into a world we barely understand. The existence of these rivers changes how we see the ocean. It's not a single uniform body of water. It's a complex system of layers, currents, and hidden boundaries. It's a world of rivers flowing within rivers, of waterfalls in the dark, and of landscapes being sculpted by forces we are only just beginning to measure. We've sent probes to the edge of the solar system, but the abyss remains a frontier. We know more about the surface of Mars than we do about the floor of our own oceans. Even with our most advanced technology, mapping these underwater systems is incredibly difficult. We rely on sonar that bounces sound waves off the seafloor, painting a picture of a world we can't visit. Each new survey reveals more complexity, more channels, more canyons. We are finding that these rivers are not rare exceptions. They are a fundamental part of how our planet works. They are the circulatory system of the deep. Think about it. A river with its own shores and waves, flowing in total darkness under miles of water. It carries the memory of mountains, the dust of continents, and the fuel for life in the abyss. It's a process that has been happening for billions of years, shaping our world in ways we are only now discovering. What we see on the surface is just the beginning of the story. The real geography of our planet is hidden beneath the waves. We've mapped the stars better than the rivers under our own oceans.